I want to thank you guys for being here today and listening about Alluxio, which used to be called Tachyon. And essentially, it is an open source memory speed virtual distributed storage system. And I'm Gene Peng. I'm a software engineer at Alluxio. So before I get started about talking about Alluxio, the software, first I want to briefly describe the company. It was founded by some of the creators and top committers of the open source Alluxio project, and it was funded last year by Andreessen Horowitz, and this is our website. You can check it out later. And here's a little bit more background about myself. I'm Gene Peng. I am a software engineer at Alluxio. I'm one of the core maintainers and contributors to the open source project of Alluxio. And before I joined last year, I was finishing up my PhD at UC Berkeley from the AMP lab, where Alluxio came out of. And before going to Berkeley, I was at Google for several years. So here's sort of a brief outline of what I'll be discussing today. I'll first talk sort of like a brief overview of Alluxio, the system. Then I'll talk about some of the motivations behind Alluxio. And then I'll go into the use cases for Alluxio. So the first question you might be asking yourself is, what is Alluxio? What is this thing that I keep talking about? Well, Alluxio, how we describe it, is open source, memory speed, virtual distributed storage system. And I know that's a lot of words up here, and it's a mouthful, but I'll sort of break it down and sort of describe different components of the system. So yeah, so what does this mean? So it's open source. It's one of the more it's one of the fastest growing projects out there in the sort of the big data ecosystem. It's also memory speed. What this means is that Alluxio really emphasizes keeping data in memory, and the architecture really tries to emphasize and aggressively uses memory. It's virtual. Essentially, Alluxio, I'll talk about a little bit later, has a unified namespace. So you can essentially, it abstracts away different storage systems for applications and developers, and it makes it a lot easier to deal with different storage systems. And also, it's a distributed system, so it's been designed to sort of scale out like many of the other distributed systems out there. So first, Alluxio is open source. I'll talk a little bit about how it sort of started. It started in 2012, in the summer of 2012. It started at UC Berkeley in the AMP lab, and the creator of Alluxio at the time was a grad student there, and this was part of his project. So he created, at the time it was called Tachyon. He created it in 2012. This is the same AMP lab that created both Mesos and Spark that's heavily used today. It was created in 2012. It was open sourced in April 2013, the following year. And it has the Apache 2.0 license. Recently, it was renamed from Tachyon to Alluxio. And the latest release that we have so far was released in February, which is 1.0.1. So this is it's an open source community of Alluxio. And it's actually been really exciting to see the growth of the contributors to Alluxio. And so here's, I think currently it's close to 250 contributors to the project. And also, just in the past year, it's grown, I think, over 3 times from like a year ago. And so here's sort of like a bubble of a lot of the top contributors. I think it's the top 100 or top 100 or so of the top contributors, relative to how much they've contributed to the code base. So it's really exciting to see how fast it's growing. And here's sort of the graph view time series of that. This is sort of the number of contributors that have contributed to the project over the existence of the project. And so Alluxio has really been around for about 3 years in the open source community. And so over those 3 years, it's grown to basically over 200 contributors. And so on this graph, the Alluxio is like the blue line. And so it's just really cool to see how fast it's growing just in the first 3 years of existence. And yeah, so I joined about a year ago, and it was around like 60 or 70 people at that time, and now it's like over 200, so it's really cool to see that. And there are also a lot of different contributors from different companies, as well as different users from different companies. And here's sort of a smaller sample of that. And it's just really cool to see how. So Alluxio is very flexible, as you'll see later. And there's a lot of different use cases that you can apply Alluxio with. And so it's really cool to see how different companies are using Alluxio and contributing to Alluxio in their work. So next, I'll talk about how Alluxio is memory speed. And what this essentially means is that the architecture heavily focuses on keeping data in memory and aggressively uses memory for storage of data. So you might be asking yourself, why should we use memory for storage? Like, why do we need to do that? Is that even feasible today? Well, I would say it is. And sort of two reasons for that. Here's the first reason. First, there is a performance trend in memory. Memory it's known that memory is always faster than spinning disks and even SSDs. And actually, memory has lower latency, has higher throughput than traditional disks. And the performance, so there's a large performance gap, but there's also the performance gap is actually increasing as time goes by. And so in order to have interactive applications, to have just quick response times, memory locality for your data is very important. So here's a graph of sort of RAM performance and disk performance, and this is looking at throughput. And on the left is the RAM, and as you see, the bandwidth is increasing exponentially, whereas the performance for disk is not increasing as quickly. So, oh yes.
Is that all spinning disks, or does that also?
So this is just spinning disks.
Okay.
Yes. Yeah. But even if you consider SSDs, the gap is still pretty large. And so so this is one of the main reasons. This is one of the motivating factors for trying to use memory for data and storage. The other trend that's been happening is that the price of memory is actually dropping, and DRAM is becoming more and more inexpensive. And here's a graph that sort of shows the cost per gigabyte of DRAM, and as you can see, it's steadily dropping, and it's sort of like the Moore's law of DRAM, maybe the opposite of Moore's law. But essentially, every 18 months or so, the cost of DRAM is becoming half. And so, if you take a look, it's becoming far more affordable to purchase a lot more RAM for your machines, and a lot of companies are actually doing this. And so maybe in the early 2000s, only a select few companies will actually do it. And then slowly, some of the bigger companies started doing it. And now a lot of even medium-sized companies are buying a lot more memory for their machines, for their clusters, and for their data centers. And so there's a lot more memory available for compute and for storage. And so Alluxio is trying to take advantage of that and try to really help manage data in memory. So you might be asking yourself, why? Yeah, what if the memory is just not big enough? What if even with all these trends, you still can't fit all your data in memory? Is Alluxio sort of useless then? Well, no, it's not. Alluxio actually manages other forms of storage medium as well. And so today, Alluxio can manage 3 different types of tiers. We call them storage tiers. One is the memory tier, next is the SSD tier, and then lastly, it's the spinning drives or hard drive tier. And so Alluxio can manage all these local storage medium on the nodes. And this is actually really useful because the characteristics of the tiers are different, and there are trade-offs, right? The highest tiers, like the memory tier, is usually the fastest and the highest bandwidth, lowest latency. However, it's probably the least has the least capacity in all the tiers. As you go further down the tiers, you get into sort of tiers that have a lot more capacity usually, but it has a lot is not as performant as the highest tier. And so Alluxio helps you manage all this data in these different tiers, although it does try to emphasize the memory tier the most. And these storage tiers are actually configurable. You can actually configure Alluxio to use just memory maybe, or maybe memory and hard drives, or maybe not even use memory and just go straight to SSDs. And so there's different ways you can sort of mix and match the different storage tiers for Alluxio. And Alluxio sort of helps you do that. So with these storage tiers, Alluxio also has sort of pluggable tier management policies to move data around between the different tiers. And this, essentially, we have pluggable policies to move data sort of down different tiers or move them up the tiers. And this is actually really useful because at a high level, you really want the data that you want. You want it to be in the top tiers. You want it to be in the memory tiers. It's the fastest and it's the quickest to get to. Whereas the data that you probably don't need soon or don't need, you want it in the lower tiers. And so with this intuition, we have these sort of pluggable policies that you can use in Alluxio to help you manage this. And so this is actually configurable, and also you can extend it. You can create your own policies and plug it into the system and use your own policies if the ones that come with the system are not appropriate. And next, Alluxio is a virtual distributed storage system. And so this is also pretty loaded. But first so I mean, it's an actual system. It's a distributed storage system, but it's a virtual system, a virtual storage system as well. And so I'll talk a little bit about that now. If you look at the ecosystem today, there are many different frameworks out there, like Spark, MapReduce, Flink, and things like that. There are also many different storage systems out there, like S3, Swift, HDFS, even traditional filers and NFS and things like that. So there's a lot of different places to store data, and there's a lot of different ways you can access that, a lot of different ways you can do computation on that data. And so this can be problematic because trying to interface with all of them can run into problems. And so what are some of these problems? Well, it can be very costly. It can be very costly to sort of integrate everything, and even costly to ETL data in and out of different storage systems. It can also be expensive in terms of getting data where you want it to the computation where you want it, where you want to do the computation on. And so that there's maybe a lot of duplication or movement that is required to manage all of this. Also, you might run into data silos where you can't really access the data in other places or in different ways, and it sort of locks you in a specific area. And it can just be hard to manage all this different data and different ways you're accessing data. And so all these different situations can really lead to longer time to extract value from your data. Managing all these things is not what you want to do. You want to actually extract value from it. And so there's a lot of different problems with that. So Alluxio tries to solve that. It tries to unify access to your data. And so it essentially is a layer. It's a system that sits between computation frameworks and applications and different storage systems that you may have. And so back a few slides ago, we saw there were a bunch of computation frameworks and applications, and there are a bunch of storage systems. And so Alluxio actually sits in between there and helps you manage that, and also provides a lot of performance characteristics as well. So by being the system in between computation frameworks and the storage systems, it really can enable new workloads across different storage systems. Instead of having to try to interface your data, try to interface on specific different storage systems for your data, Alluxio can abstract that away for you, and applications just have to access through Alluxio, and using the unified namespace can access the data in different storage systems very quickly. This also helps you to be very flexible. So you can easily add a new computation framework or application to your system. And since it just has to talk to Alluxio, it doesn't have to try to integrate with all the different storage systems out there that you may have. And finally, this is something that we've sort of been seeing recently, is that companies sometimes have been decoupling storage and computation. And one of the reasons for that is because the resources for storage and the resources for computation are actually very different. Storage usually needs a lot of storage media, a lot of disk or SSDs, and not necessarily a lot of CPU or RAM. Whereas computation resources usually require a lot of CPU and a lot of RAM. And so it can be really good to be able to scale them differently and allocate them differently, independently. And so instead of having to scale out all the resources at once whenever you're hitting some bottleneck, you can scale out just the resources that you need. And so with Alluxio, this really enables any application to access any data from any storage at memory speed. So next, I'll talk about how you use Alluxio and how it fits into your system. And so going back to the picture, it is essentially a system that sits between computation and applications and storage systems. And so here are the basic use cases that I'll talk about today. First, Alluxio can accelerate access to remote storage. It can also help you share data between different applications at memory speed. And finally, it can help you transparently manage data across different storage systems. So the first example I'll talk about is how Alluxio can accelerate access to different storage, to remote storage. And so this actually happens a lot more than you think. There's a lot of different new storage systems out there that are essentially inherently remote, meaning like something like S3 or like a Google Cloud Store or Azure Blob Store. These are all going to be remote from, typically remote from your data center or from where your computation is being done. So already the storage is remote from computation. Also, like I mentioned earlier, companies like the idea of being able to scale different resources independently. And so that's another reason why you would have independent storage and compute clusters. And so there are a lot of different scenarios where you would actually have remote storage, and Alluxio can really help with that. So I'll go through a little example. Say you have a Spark job that wants to access data in S3. So in order to do that, it would have to read from S3, has to go over the wide area network, and then it has to maybe write it out to S3. And so it can actually be very slow, and it has to go through the network. And it would have high latency and network throughput for all that data access. So with Alluxio, it looks a little bit different. So Alluxio doesn't actually get rid of the network access. It still, if it needs to access the data from S3, it still needs to talk to the wide area network. So it still would have to be slow. However, once it's in Alluxio, as long as it's close to the computation, the Spark jobs only need to access through Alluxio. And so that's much faster. And it can even be in memory, like I mentioned before. So Spark can access all the data from essentially its local cluster, maybe local machine, from its local memory, and which is much, much faster than trying to access data from S3 each time. And so keeping the data in Alluxio can really help accelerate the access to data. Next, I'll talk about how Alluxio can help applications share data at memory speed. So this is common when essentially you have maybe a pipeline or iterative computation on data. And so essentially what that means is sort of the output of one task or computation is the input of the next computation or job. And so when this happens, typically applications share that data by writing it out to some storage system and having the next job or computation read it from that storage system. And then that's how they would share data. And so this is what it might look like. Say we have this example of say a 3-stage pipeline. So we have a Spark job, write some data that the MapReduce job would then need, and then finally the Spark job would need that last input. And so in order to do this, these applications would have to read and write the data from a storage system. And so in this case, it's S3, but it could be any storage system. So it could be slow. It could go over the network. It would definitely hit disk I/O. And so there's a lot of different sources of slowness and latency involved in this. And so all the network and disk I/O can slow down the sharing of the data. Now, with Alluxio, we can actually help share this data at memory speed. So, say the first job has to read the data. Once it's in Alluxio, they can all share the data at memory speed within Alluxio, and then sort of write out that last result back to the storage system. And so, by using Alluxio, these different jobs, can share that data through memory instead of having to hit the network or hitting disk I/O all the time. The last situation I'll talk about is sort of how Alluxio can help you manage different data in different storage systems that you may have. So in the simple world, it's very easy. If you have one application and one storage system, it's very easy to sort of integrate them two and sort of work together. But that's not always possible. You might always want to be trying out new storage systems for maybe they're more cost effective. And so maybe in this case, you heard that people are using S3 to store a lot of data because it happens to be inexpensive. So you want to try that out, and you realize that it is a lot more. It is inexpensive to store S3 data, and so you have to then start integrating with S3. And then finally, you want to try out the Google version of it, so that you try Google GCS, and you have to integrate with that. And then say you have a new application that needs to access this data, you then would have to integrate with all your existing storage systems. And finally, the next application that you need would have to integrate as well. And so this actually gets very complex. It's very inflexible. You have to do sort of manual work in order to incorporate new storage systems or computation. And so this can actually be a headache just to manage. So with Alluxio can also help. In the simple world, it doesn't actually look very different from the previous world. Applications would interact with Alluxio, and then Alluxio would help you interact with the storage system. However, as you add new storage systems and applications, they only have to integrate with Alluxio, and they don't have to sort of do this multiplexing of all the different combinations of integrations. And so by Alluxio being in between computation and storage, it can really help you manage all this data in different storage systems along with the different computation frameworks you may have. It's very flexible. You can easily add new storage systems. You can easily add new frameworks. And applications don't really have to change anything. They just have to point to a different directory, essentially, that gets mounted. A new storage system can get mounted into the namespace, and applications can easily just point to that without having to change any code. So it's very, very convenient. So now I'll talk about how Alluxio is being used out there by real companies and how it's been helping them. So first I'll talk about Baidu. They've actually used this for a long time, and they've been a pretty early adopter of the technology. Yeah, so for Baidu, they use Spark SQL for their computation framework, and they use their Baidu file system. Essentially, I think it's based off of HDFS, so it's maybe a variant of HDFS, but they have a Baidu file system. And they use Alluxio configured to use both memory and hard drives for their two storage tiers. And they've deployed it on over 200 nodes, and it manages over 2 petabytes of space. And so they actually recently published a white paper. I think you can check it out on our website. And they essentially have, with Alluxio, they got 30 times performance gains using Alluxio in their environment. And so this is actually on top of just switching to Spark. So I think before they were using MapReduce or maybe Hive. And when they switched to Spark, I think they got maybe like 4 to 5x improvement. And then on top of that, after they added Alluxio to their system, they got 30 more times performance improvement. So this really has helped them out, and you can check out our website to see their study. Next, I'll talk about Barclays. They're a big bank in the UK. And they use Spark they actually use Spark RDDs and Spark data frames for their, I think, machine learning type of workloads. They configured Alluxio to just use the memory tier. So Alluxio only handles the memory for their system and doesn't use any of the other storage media. And in their situation, they actually could get, in their situation, they would essentially have to do this expensive like ETL type of process to get it into Spark. And so every time they had to restart a context or start a new context, they had to do that expensive operation again. And that took like 30 minutes or 30 minutes to an hour each time to do it. So essentially by using Alluxio, they only had to do that sort of once. And after that, they could keep it sort of in Alluxio space and not have to continue to redo the expensive work to get the data to the computation. And so they actually wrote a blog post maybe a few months ago sort of talking about how it really helped them and how they deployed it and what their architecture looks like and how it really sped up their workflow. And the last one I'll talk about is this company called Chunar. They're a company in China that I think they're sort of like an Expedia, like a travel type of website. And so their architecture is actually very, very involved. They use a lot of different frameworks. They use Spark streaming. They use Flink streaming. And those are for the streaming use cases. They also use Spark and Flink for their analytical workloads and OLAP type of queries. And so they have all these different types of frameworks. They actually have different storage systems as well. They have many different HDFS clusters. Some are local, some are remote, and they sort of need to talk to all of them. And so they put Alluxio in that system to really help them with that. Alluxio helps them manage the different storage systems, different HDFS clusters. It helps them share that data between different frameworks like Spark and Flink, both streaming and analytical type of workloads. And so they deployed it in over 200 nodes. And what they told us is that Alluxio enabled, so some jobs just would never finish in their situation. I don't know the details of why it would never finish, but it would just never finish. And Alluxio actually enabled those jobs to be able to finish. And so it enabled impossible jobs to finish with Alluxio. And also, in many cases, they got 300 times performance improvement using Alluxio. And so that's a huge number. They're actually, I think, in the process of writing a study or a blog post about this. And so I'm actually pretty excited to see what they talk about in that post. So finally, that was Alluxio. Alluxio is essentially open source memory speed virtual distributed storage system. And essentially it is a storage system between computation and storage. And it really can provide performance benefits. It can provide some cost savings as well, and also manageability of your ecosystem. And here you can find some more information. We have the Alluxio project website, has a lot of documentation. We have the company website here. All of our code is in GitHub. The open source code is in GitHub. And we have a meetup group here in the Bay Area. And you can always contact me at gene@alluxio.com. Thank you very much. Yes?
So in this use case, we try to see that various applications can connect to various stores, right? So when we want to use Alluxio, are we going to build an entire new cluster once again, or can we leverage existing Hadoop clusters of 1,000 nodes or Cassandra clusters of, say, 200 nodes and so on?
That's a good question. So the question was, do you have to provision a new cluster for Alluxio, or can you reuse a cluster that you already have? And so it really depends on the environment and workload. So it's pretty dependent on that. However, in order to get the best benefits, so for the greatest benefits, we recommend actually putting Alluxio with the computation side of things. So if you're using MapReduce or Spark, you would want to co-locate Alluxio, what we call workers, with those workers as well. And so that will actually give you the most benefit. It'll give you direct access to all your data in memory. And it's less important to co-locate with storage. So if you wanted to reuse computation, I guess, clusters that you may have, we actually do recommend using the same cluster, the computation cluster for Alluxio nodes.
And looking at Alluxio and how it works in memory, is it like going to be a resurrection of MapReduce? Because now everything can happen in memory and nothing is going to be spilled on disk.
So the question was, will this resurrect MapReduce? So I don't know, but I would say, in my mind, I think we can enable different frameworks to effectively use memory. So before, yeah, so like say in the MapReduce case, it wasn't designed for sort of the memory use case, and so Spark sort of took care of that. But with Alluxio, it matters less which framework you use, I guess. And if an organization chooses a framework, the data locality can sort of be provided by Alluxio and not have to be built into the computation framework itself. And so I think Alluxio provides the flexibility to choose the framework that best fits your needs. Yes?
Number one, the meaning of unified namespace, are you hinting that just same mounting way to mount the different storage with this Alluxio from? So presenting as a storage access point?
So,
how do you mean?
okay, so I'll describe it a little bit more, sure.
Yeah.
So for unified namespace, what we mean is that you may have many different storage systems out there. So say like HDFS or NFS or like S3 or something like that. And so what you would do is you would essentially mount those different storage systems into Alluxio's namespace. And so you can do like mount HDFS or mount /S3 or mount / whatever. And so using the same client, same interface, you can access the data in the same namespace. Yes.
Second, even in the Spark and Alluxio case, you are likely using memory, but Spark uses a lot of memory too. So in a nutshell, if you put them in the same node, you are competing the usage of memory. How do you address that?
Yeah, so that's a good question. The question was, so Spark and Alluxio both want to use memory. How do you allocate the memory? That's very specific to different workloads. But what we have seen is that, so typically Spark uses a lot of memory because you call essentially like persist or cache on RDDs. Essentially, if you use Alluxio with Spark, you don't need to do that anymore. You can save it into Alluxio instead of calling cache explicitly or calling persist.
But on the other hand, if I Spark, for example, a lot of future one and also backflow fluency, so they will manage the memory themselves based on workload needs. So the data will be collocated closer to computation, especially even for machine learning, it's more compute centric. So you are already dealing with memory, and now you are introduce another layer that you probably don't need to use because it might be like a load and you have to compute. You don't really save it right away back to the quote-unquote persistent store, no matter it's memory-based or not, right? So then what's the value add that I can get by using
Yeah, so I was saying before, that's the reason it manages it for you is because you're calling essentially, you're essentially persisting the RDDs in memory, in Spark memory, in the computation memory. And so how I would address that is essentially saying, by doing that, it's hard to it's hard to reuse that memory for anything else. So if the data was actually sort of outside of the computation framework, say it was in Alluxio instead, then that Spark job could use it, but another Spark context could use it as well, the same data. And so, I mean, it clearly depends on different use cases, but if there are many different jobs sort of accessing the same data or similar data, it makes a lot of sense to store that data sort of once in memory and not having to sort of duplicate it in different Spark's memory.
But by doing that, you need to be able to replace our memory manager layer of the application. Otherwise, you're duplicating.
I mean, there's some duplication, obviously, but there are ways that you don't have to always duplicate that data. Yes. Yes, in the back.
As a store, can you use it for writing as well? So one of the things that we have that's a source of some difficulty is one thing we do in our Spark shop is we run thousands and thousands and thousands of large n-gram queries over a Lucene index. We've been doing that against Elasticsearch for now, and what you end up with is a very large, expensive Elasticsearch cluster that's maxed out, and you end up with 10 and 15-second latencies per document on the Spark job. Both of these things are really, unacceptable. So we've been kind of looking for a way to actually have a raw Lucene cluster, or index per compute node in the EMR cluster. Obviously, just putting it on an instance store is an obvious and performant option, but the deployment of something like that is actually quite a headache, not least because when it comes time to update it, now you've got to figure out who owns it and how to make sure that it gets performantly copied back to some place. And we've been thinking about putting it in HDFS. But it's well known that HDFS and Lucene are not actually such great, companions. This seems like something that would be very promising if we provisioned, far more RAM than we actually need. Let's say used only memory optimized instances and figured that 30 gigs of RAM per EMR node was just for Alluxio to put Lucene index in. Just wrote that off for that. Is that the sort of thing that would actually work, and then we could actually write to the index in memory in Alluxio and then consider it to be updated and write it to non-volatile storage later?
That's interesting. So we haven't had any use cases, or we haven't heard of any use cases using Alluxio and Lucene. So I'm not sure if it'll work, but
I did see someone give a talk like a year ago where he was talking about Tachyon Lucene.
Oh, really?
Yeah. So
Well, then maybe it does work.
perhaps, but it's one little thing on the entire internet, and of course, as the project evolves, it's one of those things where there's probably a lot of investment of my time, and it's not going to it'd be good to have other people that had sort of been there before doing that.
Yeah. So I personally have not worked with Alluxio or Tachyon and Lucene, or I also don't know if my colleagues have either. So I don't know for sure, but I mean, maybe we can talk about it a little later. Cool.
Does Alluxio work well with Yarn, or has been tested or even been recommended to use with Yarn?
So we do have Yarn and Mesos support. I think it is easier to provide data locality if it's outside of Yarn or Mesos. But I don't know for sure. Yeah.
The reason why I ask because there are many proxy in between now. It's like Spark job for Yarn and Microservices. There's some other guy in between. So like the end result, knowing which way is the best configuration is getting.
Yeah. So I think how some people have done it is they didn't give they didn't give all the resources of a machine to Yarn. They put some of it to I guess Alluxio outside of Yarn, and then gave the rest of it to Yarn. And so that was one way they got around with to some of those issues. But Alluxio, we do have some support for Yarn. I think it's actually it's initial support for Yarn and Mesos. So I wouldn't say it's like the most either performant or hardened integration, but there is a beginning of integrations of Yarn and Mesos.
Okay, well, thanks, and let's give a round of applause for our speaker.
Thank you.